Hey guys, BuildZoid here, back with the RTX 3090 Vision that I've repaired. So we're going to do one last video with this card, mostly to show sort of the, I guess, software side of the New World failures. So yeah, and the first thing we're going to run is Furmark, of course, because nothing quite sets the GPU on fire like the spiciest of donuts. So the trick to making Furmark absolutely insane on a 3090, though I've not tried the extreme burn-in option, the fact that it says extreme actually scares me, because this is Furmark. But and I don't feel like replacing power stages again, so like it is actually very difficult to do. The VRM is rather cramped. But below that we have post effects, and post effects already does some insane things to the 3090. So let's start Furmark, shall we? So the post effects effect is actually that weird blur effect that we have around the edges. And what I want you to notice is the fact that the card is running at 0.72 volts and 1200 megahertz. It's also riding the power limit. It is right up against it, right? It is right up at like 350 watts, 97% TDP. For some reason, this card really doesn't like hitting 100%. That's probably for the best. Yeah, so that's fun. Also, if I set this to max, you'll see that the actual initial startup hit a 380 watt peak, which is quite a power limit violation. And the reason that happens is because NVIDIA's power limit is average-based, not peak-based. Like, this is the thing that annoys me to no end, is that people are like, oh, the OCP won't trip because it's like the transients are too fast. No. The OCP would trip if NVIDIA actually had the OCP set to a reasonable level. But the thing is, NVIDIA's whole idea behind how they do their power management is they just kind of let the really fast transients go, and they only concern themselves with average power consumption. So the average power consumption is pretty well controlled, but the transients are just kind of left to do their own thing. Which was the whole point of the previous video discussing the hardware of the 3090, because like the overcurrent protection is set up to basically never trigger, and the overcurrent limiting is set up to be extremely generous. And so all you're really left to rely on for power management on a 3090 is the slowed down current power monitoring from the shunt resistors, which is after the entire VRM. Like, the voltage regulator isn't actually being used for power management, really. It's just, you know, sort of a last line of defense for when the software does... Well, it's not even a last line of defense because the OCP's set too high. But anyway, so yeah, the initial startup actually peaks pretty high, but after that, you know, it sort of settles at 350 watts because Furmark is a very consistent load. It's extremely heavy, but it's always extremely heavy. So it's really easy for the software to just sort of go like, okay, we'll just underclock the GPU to 1200 megahertz and 0.7 volts, and it'll stop violating the power limit. And so you get this scenario where the card just kind of runs at incredibly low speeds, at very low voltage, and still pulls an incredible amount of power because the thing is, like, Furmark is actually probably as close to 100% core utilization as it gets. Now, for some reason, GPU-Z says this is only 97% load. I find that very hard to believe. I have not found any software that runs as heavy on this card as, like, Furmark does. And the thing you need to understand about chip power consumption for, like, CPUs and graphics cards and all of, well, CPUs and graphics cards, basically, is that the power consumption is directly reflects how many transistors are active, right? And the higher the voltage at which those transistors are active, the higher the power consumption. The higher the frequency at which those transistors are being switched at, the more, you know, the higher the power consumption. And so when you have Furmark, like, you know, running like this at 1200 megahertz, which is a very low frequency, and 0.7 volts, which is a very low voltage, but it's still pulling incredible amounts of power, that tells us many transistors are active, right? And the 3090 does have a hell of a lot of transistors. It's got 10,496 CUDA cores. It's an absolutely gigantic piece of silicon. So it's not really that surprising that, You know, if you find a sort of hyper optimized GPU workload like Furmark, you can end up with this kind of insane power draw, because that's kind of the thing, is like Furmark's number one priority is to be as heavy a GPU workload as possible, right? Like, this is the most optimized rendering of a fuzzy donut with some blur filtering that there has ever been. You're not gonna get a spicier donut than this. Whereas most games are actually concerned about producing, you know, pretty visuals instead of making those visuals use as much of the rendering capacity of the GPU as possible. So, yeah, that's kind of the thing. Because one thing that's been really bugging me with this whole New World discussion is that a lot of people have been saying that New World is like unoptimized and that's why it's killing GPUs. But it's like, that's not how software works, right? If we like simplify this to CPU terms, because quite frankly, I don't know anything about GPU programming. What is worse for your what is going to be worse for your CPU's power consumption? A single-threaded, you know, memory-bound search algorithm, or a multi-threaded AVX512 accelerated number crunching algorithm? Is pretty simple. It's going to be the 8-core AVX512 accelerated number crunching algorithm, because that uses more of the available transistors in the CPU than the search algorithm that's constantly waiting for memory access because, well, it's memory bound. Like I literally defined it as being memory bound, so it's constantly waiting for memory access. Therefore, and also it runs on one core, so even when it's not, you know, starved for memory access, it can't really run that quickly because it's running on one core. So you have to sort of consider, and GPUs are basically many cores, right? So that whole example of like very badly multi-threaded software versus highly multi-threaded, well-optimized software, and the power consumption difference you get between them on a CPU, like that also heavily applies to GPUs. And so with modern GPUs, to some extent, they're not really designed for 100% load, because there's not really anything, like, under normal circumstances, right? I do not consider Furmark normal circumstances. Under normal circumstances, you're not going to see this many active transistors in a 3090. Like, you just won't. There's no way a game developer is going to get their game to run so efficiently that it can replicate the power consumption behavior of Furmark. It's just not happening. What you can end up with is a game developer having, say, moments during which the rendering process is hyper-optimized, right? The whole frame render might not be, but there might be bursts of incredibly heavy load where they've nailed it as far as the rendering is concerned. And I would assume that's kind of what happens with New World, where it's like, for moments every time it renders, like for maybe a millisecond or a couple milliseconds every time it renders a frame, it absolutely slams the VRM. And it would happen every frame because the sort of biggest transient load that you actually... So the transient loading of a GPU is directly tied to the frame rate. Like, you can literally count how many frames a GPU is rendering by looking at the power transients on the power, like vCore power rail. Yeah, like this idea that like 1,000 FPS is significant, like 1,000 FPS is a different transient load from like 10 FPS. But at 10 FPS, each transient event is longer, and happens less frequently. And at 1,000 FPS, each transient event is shorter, or more like each load scenario is shorter, but happens more frequently. And so neither of them necessarily, you know, is inherently going to be worse than the other. But anyway, I do want to try rerun Furmark because I find it really interesting that I can get it to spike right at the start. So we're going to let the card cool down maybe a little bit. Actually, maybe not, because if we started at a higher temperature, there's going to be more leakage. Okay, so it ramped up to 372, and then it levels off. Yeah, so you can sort of see the behavior of NVIDIA's like boost algorithm, where it's like, it's average-based. 369. Okay, so it looks like it's learned that I'm slamming it with Furmark right now. So it won't let the card get slammed properly. Okay. Anyway, the other thing I wanted to show you is Unigine superposition, because this is the one 3D workload that I've found that manages to consistently violate the power limit of this 3090, and I haven't run New World on it because that would require like installing, well, connecting the test bench to the internet, and then probably spending several hours waiting for updates, and then buying New World and like installing it, and quite frankly, I don't feel like dealing with all of that. And also I don't really feel like having to replace a power stage again. So even if I did go through all of that, I wouldn't run it on this card because I'm pretty pleased with like replacing power stages is not fun on 3090s. The PCBs suck up a lot of heat, and there's like the VRM is cramped on especially like the reference style cards. Some of the, I think like MSI cards are probably going to be like, would probably be the easiest because MSI likes to have big open PCBs with bunch of empty space. But yeah, this is not that. This is very cramped. Anyway, so let's run 8K superposition, which runs at a grand like 4 FPS, and absolutely demolishes the power limit on this card. And my theory for why that happens is that Unigine superposition seems to be really well optimized. We might get lucky and we might get the transient after the loading screen instead of during the loading screen. Basically, as soon as it starts loading in assets, it starts causing issues. But, I mean, we've already violated the TDP by... Yeah, okay. Like, as soon as the render tries to start, we hit 111%, so that's great. Now we're at 412 watts. If you run this for long enough, sometimes it'll spike higher, but yeah, a lot of the time it hits the highest spike right at the start. It does hit more spikes throughout the run. The thing is, I can't reset the monitoring because superposition is extremely buggy, which is really annoying. I wish I had a shortcut for resetting. Because if I hit the reset button, it's just going to crash superposition, as you can see. I mean, it still managed to catch another TDP violation before superposition managed to crash, but yeah, and then superposition just crashes out, which is just so frustrating. Anyway, where was I? Right, so basically, NVIDIA has an average-based power limit that just doesn't deal well with transients because it's not supposed to. And so if you have a piece of software that has, moments where it hits incredibly high utilization because it's really well optimized, you end up with massive power draw spikes, which the VRM is set up to basically ignore. Right, like this is the thing I want to make clear. Like, it would be a very easy fix to just set the current limit on the VRM to like 600 amps. I think the only issue with doing that is the VRM would shut down randomly under regular usage. Oh, and the other thing I wanted to mention is I think 8K superposition specifically is so good at doing this because the combination of this incredibly low frame rate, right? It's running at like 4 FPS, and the fact that we're rendering an 8K resolution image means that we have like plenty of work for the CUDA cores to do, right? Like, again, the card is huge, and it's a well-known fact that really big GPUs generally scale to higher resolutions, right? You can just think of like the Fiji cards and how those were generally did somewhat better at 4K than they did at 1080p. And then also you have and 3090s also show that, like a 3090 actually has a bigger performance gap to a 3080 at 4K than it does at like 1440p or 1080p. But even going from 1080p to 1440p, the 3090 is starting to pull away. So basically, the more pixels you can throw at a 3090, the more useful all of those extra CUDA cores become. The side effect of getting more usage out of all the extra CUDA cores is that your peak power consumption goes up. So that's not really great for the health of the power delivery, considering that the card is basically set up to just kind of ignore the really, really, really high transients. Right? Like, there is a lot of averaging that goes into the power limit of a 3090. And I think we might just have to drop out of Unigine superposition because it's unfortunately running at such low frame rates. Well, maybe, yeah, I don't want to reset it again, so we're just going to leave it. And if we scroll through this, or actually, it'll be easier to see it here. So you can see, like, here we have a 105%, 100, like, it regularly spikes over 100%. Unfortunately, the software is not, super. I can't reset it while it's running, which is a shame. Um, and GPU Z is set to refresh at 0.1 seconds. So this is 10 times a second update rate. And we're already catching like plenty of deviations above the power limit of the card. And that's on a card that normally doesn't really like to go above like 97%, right? Like if we run this at 1080p, actually, let's run it at 1440p, which isn't going to run like crazy high FPS or anything, or even like going to be like low utilization on the GPU, I don't think. Right? Like that just sits at sort of like 362 watts. GPU load at 99%, but because we have less pixels to work on, the GPU doesn't have like peak loads that are as high, and because of the high frame rate, those peak loads aren't sustained for as long, so I would assume that's why we're not actually catching them on the board power draw monitoring, because those peaks are too short, possibly slightly lower as well, and so we don't see them. So this is much easier for the like average based power limit to deal with, and I would assume that New World basically just, like, most of the frame is fine, and then there's one part of the frame that just looks almost like Furmark, and that might happen for like a millisecond. So NVIDIA's power management just kind of lets that go. And then it goes back to being, and like the thing is you have an idle period between frames as well. So like GPUs, in terms of their power delivery demands, are kind of ridiculous. Yeah, like the 3090 sort of takes that to its extremes, because this card is just constantly power limited, right? Like constantly. We have a very, very, very big GPU core with a really aggressive power limit relative to what it is, right? Like arguably NVIDIA could have shipped these cards with the same power limit and less boost. And that would have made them less spiky. But instead we have the current, because the thing is the boost algorithm is sort of reactive, right? Like it's not going to throttle the card. This isn't like Intel CPUs with AVX instructions, where if an Intel CPU sees an AVX instruction, it preemptively throttles itself so that it doesn't suddenly pull way too much power, because the problem with Intel's sort of preemptive throttling system is that if you have even one AVX instruction amongst a bunch of regular instructions, the whole chip downclocks itself by like 200 or 300 or 400 megahertz, and you lose a bunch of performance because there was one AVX instruction somewhere in what the CPU was doing, and then you've just lost a bunch of performance for no reason. So with GPUs, you don't do that. At least as far as I know, with GPUs, you don't do that. First, the GPU violates the power limit, and then the power management pulls the clocks and the voltage down to sort of stay within the average power target. Whereas CPUs do it CPUs have done it the other way around, where it's like, okay, you see an AVX instruction, you underclock first, and actually you don't clock up ever again. Like the moment you see AVX, you just downclock and you sit at those lower clocks. Or GPUs don't do that. So yeah, that's kind of that. So you first get like an initial, like the spike first happens, and then the power management response. Not so much the power delivery. Like the power delivery is going to provide, because the thing is, the card. A common misconception I see is the card does not request power from the VRM. It basically just kind of grabs it, and the VRM has to just deal with that, right? And so if the card suddenly tries to pull 600 amps, the VRM will provide 600 amps to the best of its ability. And if it can't provide it, it will either cause the voltage to drop so far that the card can't run stably and it crashes, or it'll burn up components, or if your VRM actually has any safety features built in, it'll just shut down. One of these three things is going to happen. So, yeah, that's kind of the thing, which NVIDIA GPUs, as I've established in the previous video, just kind of don't seem to have any kind of safety functionality built into the VRM, or at least what safety functionality there is configured to be extremely generous in the wrong direction. So yeah, and so when you have, very bursty workloads with, yeah, like really bursty workloads, NVIDIA's power management approach just kind of doesn't really work. And I would also imagine over time that 3090 reliability is going to go down. Not like, because if so, like New World is currently like the first example of a game that like very consistently is breaking 3090s. But I would imagine over time, as say like monitor resolutions increase, because again, the superposition 8K is really bad in my experience for this 3090 here. Evidently not as bad as New World because I've not had to replace a power stage again, but is pretty bad. Like this thing is exceeding its power limit by like 10% or more. So I'd say that's not a great thing, and that happens specifically at 8K. At 4K, it violates the power limit a little bit, but nowhere near as much as it does at 8K. Like 8K is by far the worst load scenario that I found for this card. So I would assume that even for other applications, though I've tried this with the various 3D marks, and actually running those at 8K doesn't seem to really do anything. So though Unigine Valley, which I can't get it to run at as high a resolution, but Unigine Valley has managed to also get closer to the max TDP more frequently. Actually, I think I might have gotten it to slightly exceed it once or twice. So it really seems like, depending on, like, it heavily depends on which, engine, 3D rendering engine we're talking about here. But I would assume over time, as developers get better at optimizing for massive GPUs like the 3090, and as monitor resolutions go up, this kind of really high peak load scenario is going to become more common as people get better at using 3090s, which is not great for the prospects of the endurance of these cards. Yeah. I might be, and this is, I should say this is all speculation on my part. But I can't see any other, the other option is that we just have a bunch of faulty power stages coming out right now, which, I don't know, maybe the component shortage means that we do have a bunch of faulty power stages floating around, but I'm really leaning towards the just 3090s kind of overloading their power delivery, and the power delivery isn't really designed to do anything about it. So the only other thing that can happen happens, and that's the components start failing eventually. Because, yeah, the power, the peak power draw that these cards can achieve is just absolutely ridiculous. The only thing is it's actually really hard to achieve that peak power draw, right? Like, Furmark goes out of its way to be as heavy as it can be. And so a lot of games just don't have the ability to use all of the available compute resources in a 3090. But, yeah, that's my thoughts on the situation, is just so over time, if anything, this might get worse. And also over time, these cards are just going to wear out the components, right? Power stages don't last forever, and they especially don't last forever when you run them close to their limits. So that's kind of the thing, is just I don't know, maybe in 2 or 3 years, we're just going to see a flood of dead 3090s. Sort of like it's not very difficult to find dead 980 Ti's these days. And especially the reference cards tend to have blown up power delivery, so yeah. Anyway, I feel like this video has gone on for way longer than it needed to, but I've tried to reshoot it 4 times, and it's not been getting better, so I'm just going to upload this version, because I think I've gotten all the points that I wanted to get across. And again, this is heavily speculation on my part, but, this card can pull, the card, as far as I can tell, isn't designed for 100% load, which is why it's constantly power throttling, and NVIDIA's average-based approach to power management is just not going to deal with, peaky workloads at all. it's not designed to handle that, and so it doesn't, and then you get failed components. And that's probably going to get more common over time, if anything. So, yeah. Anyway, that's it for the video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you'd check them out. And yeah, that's it for the video, so thank you for watching, and goodbye.